Hi everyone. I made this video just to recap some of the things from Trig. So this was just to be considered a homework assignment, so I just wanted you to try your best. So if you completed it on time, you got 100, and then you might have lost some points if you turned it in late. But I wanted you to have this option just to refresh back on, just in case you had any trouble doing it. So in the first one here, notice for number 1, we're looking for this length of CD for both A and B. So we're looking for this side. Remember, everything is based off the angle. So from this angle of 32, the opposite side is the one that does not touch the angle at all. The hypotenuse is always across from the 90-degree angle, and that means the remaining side is the adjacent, the side next to the angle that's not the hypotenuse. Now, the whole point of this whole unit comes down to the phrase SOHCAHTOA. So I look at to see which sides we have. We have a number on H, and we are looking for A, so that means we're using the trig function cosine. So cosine is always paired up with the angle, so 32 degrees is equal to x over 75, and we cross multiply. So it's going to look like x equals 75 cosine of 32. And then I let the calculator do the work for me. So remember, your calculator must be in degree mode. And it said to round to the nearest tenth, so 63.6. I'm going to do the same thing over here for B. Now we're looking for CD again. So X is here. From the angle, I have the opposite, hypotenuse, adjacent. From SOHCAHTOA this time, notice I have something on O, and I'm looking for H. So it means I'm using the trig function of sine. Sine of the angle measure 56 is equal to 28 over x. I'm going to cross multiply by sticking this over 1, and we'll end up with x equals 28 divided by sine of 56. And now again, we're going to plug that into the calculator. So the nearest tenth, we're going to get 33.8. In number 2, we're going to do things a little bit differently. Still looking at an A and B situation here, but we're looking for angle A. So again, we're looking at what we have. The opposite's the side that does not touch. Adjacent is next to. Hypotenuse is across from the 90 degree. So notice I have numbers on A and H. So back to SOHCAHTOA, that means we're using cosine. So cosine of A, the angle measure we're looking for, is equal to the adjacent over the hypotenuse. Now, when we go to plug this into the calculator, it's different. Anytime you're looking for an angle, we're going to put the inverse of that trig function in there. So the way we access that in the calculator is hitting the second button and then cosine. And we'd have 6 divided by 10. And when we round to the nearest degree, we would get 53 degrees. Oops. Same idea for B, but we're still looking for angle A, remember, which means we have the opposite, the adjacent, and the hypotenuse. Because we have something on O and A, that means we're using tangent. So same thing, tangent of A is equal to 20 over 28. Angle A is going to equal the inverse of tangent. So again, we plug that into the calculator. Second tangent, 20 divided by 28. Round to the nearest degree is 36 degrees. Okay, now, so number 3 said to be careful. So notice I have an isosceles triangle. And we're given that the legs are 12 degrees. So remember, an isosceles triangle has 2 congruent sides, and they're known as the legs. I also have base angles that measure 28 degrees. So we dealt with a question similar to this, but we haven't done this exact question at this point in time. The thing that you have to remember about trig is that we need a right triangle. So I'm going to draw in the altitude. Now, notice what I've done by doing that. I have this right triangle now, where I still have 12, and I have the base angle of 28. And we're looking to find the base. So I can find this piece right here. So then I do the same thing as question number 1 now. We don't have anything on the opposite. We have the hypotenuse and the adjacent. So I'm going to use cosine. Cosine of 28 equals x over 12. We stick it over 1 and cross multiply. We get 10.5953. Now I'm being careful here because I don't want to round just yet, even though it said nearest 10th, because the problem is we've solved for this piece here. To get the full length, we still need to go back and multiply by 2. We need to know that in an isosceles triangle, this altitude cut it into 2 equal parts. So I'm going to go into my calculator and just let the calculator do the work by hitting times 2. We get 21.190, and now we're ready to round to the nearest 10th of 21.2. Okay, on the next page here, same idea with number 4. Right, we have a ladder leaning against a building that is perpendicular to ground such that it makes a 74-degree angle with the ground and lies 2.5 feet from the base of the building. Determine the height of the ladder that reaches up the wall to the nearest 1/10 of a foot. So we're referring to the height up. So we're referring to this side. So from my angle, that's the opposite. We already know the adjacent. So that means we're using tangent. Okay, so we cross multiply. And let the calculator handle it for us. $9.59. So we get 9.6 feet when we round to the nearest 1/10 of a foot. Now in the next one, you could do one of 2 things here. So it's asking us about how long the ladder is. So we're talking about this side here, the length of the ladder. So I'll call it y. You could do one of 2 things. We could do trig again, or you could do Pythagorean theorem. A squared plus b squared equals c squared. We just calculated what the second side was, so you can do it either way. I'm just going to do trig since that's our big focus here, though, so we're still using this. Now, this is still the opposite angle. This is still the adjacent, and this is still the hypotenuse. So this time, I could really use any trig function I want. I have two sides, so I could really play around with this. But since I want to get the hypotenuse, I'm going to say I want sine or cosine. So I'm going to use cosine. Just in case I calculated anything incorrectly in part A, then I still could use this. So cosine of 74 is equal to 2.75 over y. After cross multiplying, y is going to be equal to 2.75 divided by cosine of 74. We plug into the calculator. And in this case, because we want to round, we just want to double check where we're rounding to the nearest foot, it's going to be 10 feet. Okay, so 5, 6, 7, they all have the same kind of concept in mind. The big idea here, find the value of r that will make this true. Well, remember what sine and cosine are. They're known as cofunctions. And this piece here between 0 and 90 means my degree measure has to fall somewhere in between. So if you're really not sure, remember you can plug into the calculator till you find it. But our angle measure, so 73 and r, should add up to 90 degrees. So when I subtract 73 from both sides, angle r is equal to 17 degrees. The reason why is cofunctions are equal when angles are complementary, aka the two angles add up to 90 degrees. So I'm going to put complements in there and I ran out of room. But that's the same idea for 6. Because notice here, we have Alex wrote the equation to find HJ, this piece here. So that's the opposite and the hypotenuse. So he used sine of 28. That's great. Marlene, however, she used 62 degrees. So we're wondering where that 62 comes from. Remember, a triangle has to add up to 180 degrees. So if the angle J is 90, G is 28. When I add that up and get 62, we're talking about this angle now. So that's changing it to have the adjacent and the hypotenuse. So she's correct also. And that should work out. So when I go to do the explanation, I could just explain how they both did complete correct setups using trig by SOHCAHTOA and because triangles add to 180. Or I could talk about cofunctions are equal when the angles are complementary. Anything like that. There's a bunch of explanations that would have counted in this case. And finally with 7. First, I'm looking for write a trig ratio based on the information given for L and N. So if I first find L, I'm looking at my adjacent and the hypotenuse. So that means it's cosine. And then if I'm looking at angle N, it changes because now this is the opposite, but the hypotenuse is still in case. So that's sine of L equals 4 over 5. Solve for both of these measures of angle L and angle N. So remember, we would do the inverse in the calculator. Second inverse, 4 divided by 5 for the first one. Second inverse of sine. So I'm looking at 37 degrees and 53 degrees. And the relation between them is they're complementary. And again, this comes down to cofunctions are equal when angles are complementary.